So hello everyone, welcome to yet another video. Today we will be going to discuss about a project which I made as a part of a hackathon that is organized by IEEE, that is the Institute of Electrical and Electronics Engineers. So let's begin. So this is the dataset that we have been provided with. It's a time series data. So from this data we need to predict the carbon monoxide concentration and the temperature for each and every hour of a day. But as we can see over here, this data is clearly not a clean one, and we need to clean this messy data in order to make some future predictions. So let's do that with the help of Python. So this is how our code looks like. First we begin with importing the various packages like NumPy, Pandas, Cbone and Matplotlib, and then we just uploaded the data and read that. So here's how we read the data, and clearly it's not a clean one. So let's begin the cleaning part. So in this data cleaning, we first we made use of dictionaries, lists and various inbuilt data types to collect the to gather that data and convert it into some useful format. So like this. Now after cleaning the data, our data set looks something like this. The timestamp feature contains all the date time values of each and every hour of a day, and then the COGT column present here depicts the the amount of carbon monoxide that is present in the air and the temperature in degrees Celsius. After converting it into this particular format, then we came to know that there is an anomalous value that is -200. So for that we converted into we converted all the -200 values into a NaN value. Okay, so after that we just checked for all the missing data that is present in our data frame. So we can clearly see from this graph, this heat map, that in the COGT column, that is the carbon monoxide concentration column, we have certain missing values of data. Then in order to fill those missing values that are shown in this graph, like by these blank spaces, we simply use the linear interpolation. So here we use the linear interpolation in order to fill those NaN values, and then we simply divided our dataset into a train and test data. Now as per the instructions given to us, we need to train our model over 7 days. We need to do the predictions for the next day, and similarly then I update the database and make the predictions for the 9th day. And after that we just perform the exploratory data analysis. First we begin with the COGT column, that is the carbon monoxide concentration column, from our train set, and we just perform the seasonal decomposition. So this is how our observed value, trend, seasonality and residuals look like. And similarly we perform that for our temperature data. So clearly we have an increasing trend over here, and this data set is also looks seasonal. And after that we plotted the autocorrelation function plot for the COGT column and the temperature column. So this is how our ACF plots look like. So from these autocorrelation plots, we just derive these lags, how many lags, previous lags are seem to be important in order to predict the next future value. So we just noted down those values, like the first, second lag and the 22nd, 23rd, 25th lag seems to be important in the COGT column. And in case of the temperature column, the second, third, fourth, fifth and sixth lag seem to be important. Similarly, it rises for yet another time in these lags like 24, 25 and 26. And we just define the function to calculate the RMS of RMS values that are given in a list, and because we will be using it in the feature engineering part to create a feature that has all the rolling window of RMS values. Okay, So the RMS value of past 3 lags that we will be using. And here's how we did the feature engineering part in just one function by just defining one particular function. So here we made use of some if-else conditions, helping us to do different feature engineering in the temperature column and different in the COGT column. And we just defined all the lags like lag 1, lag 2, lag 3, 22, 23, 24, 25, and in case of the temperature column, the lags 4 and 5 are also important, as can be seen from the auto correlation function plot. Okay, so after that we just made use of these we just derived some features from the date variable, like what is the hour and what are the days, and then the day of the week, like Monday, Tuesday, Wednesday, Thursday, Friday and Saturday, like 0 to 6 denoting Monday to Sunday. Okay, and then we just use the RMS values for the past 3 lags so as to create a rolling window for them. And then this column denotes those RMS values for past 3 lags for each row. And then we have columns like expanding mean and expanding standard deviation. And then after performing the feature engineering in the COGT column, it looks something like this. This is the output that we have obtained from this from this function. So these are the columns like lag 1, lag 2, lag 3, 22, 23. All the important lags are listed here, and then the rolling mean is there for past 3 values, and rolling standard deviation, the hour, day of week, the RMS values, expanding mean and expanding standard deviation. So let me tell you all first that we made use of machine learning to predict this time series data. Before that, we also tried out different neural networks and different models like ARIMA and exponential smoothing methods, but this seemed to perform way better than those, so we tried out this approach, and we carefully performed the exploratory data analysis. Like on Mondays, that carbon monoxide concentration is little bit on a higher side, and it comes to a decline. It starts declining from Friday onwards. Like Saturday is a little bit low and Sundays is even lower, and Thursdays is there because on Thursdays we a lot of our data was got removed from our data set. Now, one reason for this such a low value on Thursdays is that we missed a lot of our data because we used rolling windows, and due to that reason we created some nan values, and then we need to drop those nan values. So that's why our most of our data of Thursdays got missed. And then moving ahead, we just plotted on the basis of time the CO concentration on the basis of time, and it seems like on between it's low at around 5 according to the international time, and it's high a little bit on the higher side at about 20. So, and after that, then we just plotted the carbon monoxide concentration on the basis of various dates that we have in our training data set. So it seems like on 15th it was a little bit high, and on 11th it was a little bit low. Again, the fact that we used rolling time windows, so we missed a lot of our data on the 11th of that month. After that, we just created a new data frame as a new DFT, and after doing the pre-processing stuff on the temperature column. So here, as we can see, there is a slight difference. We have the lags 4 and 5 as well, just because just as I explained earlier, that lags 4 and 5 are quite important for the temperature, but they are not important for the carbon monoxide concentration. So that's why we made use of them in this temperature while predicting this temperature column. And then we just created all those plots. Similar to that, Similarly, our Thursdays our concentration, our temperature is quite low because we missed a lot of data. And similarly, we just plotted our temperature at different times. But from this graph, we didn't came across some any useful information, like just the general facts are presented. In between 5 to 8, the temperature is a little bit on the lower side, and at about 3 or to 4, the temperature is quite high, which is general. And then we just splitted our data into train and test using this function that is split. So in this function, we give the data frame and the split point at the point which we want till which we want our train test to be. So after that, we just imported different machine learning algorithms and installed cat boost, because as we all know that cat boost is a very good boosting algorithm. And then we just imported different libraries, and then we just defined this predict function that just creates a new row to test and predict one step ahead. So this does nothing but just create a new row for the next step using the previous data, and just predicts one step ahead, like for an hour ahead. And then we just imported the mean absolute percentage error from sklearn metrics, and then we created lists like losses, y true and y pred. So here's how we fitted the model, that is gradient boosting class regressor, after comparing different machine learning algorithms, and as we can see where it gave us very good results. We got a very low MAPE of 12.37% between the actual values and the predicted values, and as we clearly how close the predictions were obtained from the model. And similarly, we just predicted for the carbon monoxide concentration as well. Here we got the MAPE loss of 36.35%. So this is also a little bit close. It can be further improved by deriving some more features and by doing some hyperparameter tuning. So that's all for today. See you all later. Bye bye.